Okay, today in IM2 we're going to start a review of some concepts that you might have missed in IM1. If you start the video and you see a lot of familiar, then you can pass, or you can just go skim through it just to make sure you're familiar with everything that I tell you about. So what does it mean to prove something? Think about that. Have you ever heard of James Clerk Maxwell? Well, he's a Scottish physicist who developed a unified theory of electromagnetism in the 1870s and predicted the existence of radio waves. He didn't prove it, he predicted it. And then along came Heinrich Hertz, a German physicist who conclusively proved the existence of electromagnetic waves that was predicted by Maxwell's equations in 1886. So think of the word theory that you've heard before in many different ways. Have all of those theories been proved? This one has. Okay, in Chapter 6, we're going to have the opportunity to prove things. We're going to prove statements that we believe. We're going to use protocols just like a scientist, but they have to be specific protocols, and we'll learn all about how to put a proof together. But before we start the chapter, we need to review some of the material that is now covered in IM1 but might not have been covered last year because of the shortened year. So there's a lot to cover, so I recommend you pause the video and read the information yourself, or read it in your IM1 journal if you still have it. I am not going to read each thing step by step, word by word. But these are the building blocks that will help you develop the logical thinking skills that you need to create proofs. Okay, in geometry, these words, point, line, and plane, are undefined terms, but people have agreed on what they mean. So here's a point. This is a line. Okay, read this all to be familiar with it. A plane has two dimensions. Collinear points are points that are on the same line, and coplanar points are points that are on the same plane. Notice that this is the name of the plane. It has no dot, so be careful with that. Okay, these are defined terms. So a segment and a ray are here. So a segment has two endpoints and it stops, AB. This is a line. We've already learned about that one. A ray has one endpoint and then has an arrow off to the other point. Notice that the symbols on top help define it. Okay, a line has two arrows at the ends. A segment just has a line, and a ray has an arrow. It always starts with the endpoint and has the arrow go that way. Opposite rays are explained by CA is an opposite ray to CB. Okay, congruent statements. Line segments that have the same length are called congruent statements. You can say the length of AB is equal to the length of CD, or you can just say AB is congruent to CD. Notice the differences. The length is equal to the length. This would be different than saying AB is congruent. So the difference is between the equal and the congruent, and we're going to go over that in a later slide. So when three lines are collinear, you can say that one point is between. So B is between point A and C. However, E is not collinear, so we cannot say that it is between. So we put this information together and we have the segment addition postulate. This is one that you need to know. And it's if B is between A and C, then AB plus BC equals AC. Complementary and supplementary angles should be familiar to you as well. Complementary angles are angles that add up to 90 degrees. They can be adjacent to each other, and we'll learn, which means they share one side and they have a common vertex, or they can just be two angles that are on in different things that add up to 90 degrees. Supplementary angles are angles that add up to 180 degrees, create a line if they're adjacent, or they can just be two angles not attached that add up to 180 degrees. Adjacent angles are angles like I described up there that have a common side and a common vertex. Angle 5 and 6 here are adjacent angles. 7, 8 are non-adjacent angles. So in this figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So for complementary angles, we look for two angles that add up to 90 degrees. So that would be this one, 28, and 62 are complementary. Okay, if we're looking for supplementary, then we're looking for 180 degrees. That would be 72 and 108. And then when we're looking for a pair of adjacent angles, it would be angle DEG and angle GEF. Linear pairs and vertical pairs. So two adjacent angles are a linear pair when their non-common sides are opposite rays. So this is the non-common side and their non-opposite rays. In other words, they create a line. Two angles are vertical angles when their sides form two pairs of opposite rays. The easiest way to see this is to look at opposite angles. So angle 3 and angle 4 are vertical angles, and angle 4 and angle 5 are vertical angles. One important thing that you need to remember is whenever you're writing a proof, you have to establish that two angles are linear pairs before you can use that to prove something else. For example, if I wanted to prove that angle 1 plus angle 2 equals 180 degrees, I would first have to say angle 1 and angle 2 are a linear pair. And that would be the definition, the statement, the reason would be definition of a linear pair. And I can see that they're a linear pair. They create a line. Then I could say angle 1 plus angle 2 equals 180 degrees. And I would use the proof that I'm going to learn in a little bit to state that. Okay, same for vertical angles. You would have to establish that angle 3 and angle 6 are vertical angles, and definition of vertical angles. And then you would use the proof that we're going to learn in a little bit to use to find that they are equal. Okay, so now we're going to look at some examples. We're going to identify all of the linear pairs. So 4 and 3 are linear pairs, 1 and 2 are linear pairs, 4 and 1 are linear pairs. Okay, so you can just keep going and find all sorts. 3 and 2 are linear pairs, and you can see that there are 8 sets of linear pairs in this diagram. Also, they wanted you to identify the vertical angles. So we can see that 4 and 2 are vertical angles. Angle 1 and angle 3 are vertical angles. Angle 8 and angle 6 are vertical angles. And angle 5 and angle 7 are vertical angles. All opposite angles are vertical angles. Angle 4 and angle 2 are congruent. So that's why they are vertical angles. Do not mistake this linear pair for vertical angles. Okay? All right, now we're going to get to some of the logical part of this. So a conditional statement is a logical statement that has two parts, a hypothesis P and a conclusion Q. When a conditional statement is written in the if-then form, the if part contains the hypothesis and the then part contains the conclusion. You would write it if P then Q, and this is how you would write it in symbols. Okay, so they're giving you a statement and they want you to identify the hypothesis, and the blue is to identify the conclusion. So what I did was I put the solution up here so that you can see it. So I noticed that the hypothesis is that if this is a bird, and the feathers is the conclusion. Notice this one is written backwards because you're in Texas. If you are in Houston, the if statement is going to be our hypothesis. So if we were going to write these in if-then form, if an animal is a bird, then it has feathers. You can't say if it's a bird, you have to say if something's a bird. So you want to be specific. If you are in Houston, then you are in Texas. Okay, so when is a conditional statement true or false? That is something that you have to learn to understand. Okay, so what you're going to do, it's going to tell you right here, a hypothesis can be either true or false. The same is true of a conclusion. For a conditional statement to be true, the hypothesis and the conclusion do not necessarily both have to be true. So I'm going to leave these for you. You need to push pause and see if you can decide if the whole statement is true. Remember, the whole statement. And then you're going to look at the answers and see how you did and try to understand if you made any errors. So push pause. Okay, there are the answers. Go through them and make sure you understand them. Okay, here's another set of conditional statements. Again, I want you to push pause and decide if they're true or false. When you're done, then look at the answers and see if you understand. Push pause. Okay, hopefully you understand each of those. If you don't, you can ask me in class. Okay, a negation of a statement is the opposite of the original statement. These are pretty basic. To write the negation, you put this symbol here. Looks like the approximate sign, but it means not P. So write a negation of each of these. Remember, the key word is opposite. So the ball is red, the ball is not red. The cat is not black, the cat is black. Okay, now we're going to talk about related conditional statements. Okay, and these are not something that I will test you on, but they are something that you need to understand, and they're the kind of questions that come up on SATs, so you really want to understand. So the first statement you have is your basic conditional statement. If P, then Q, written like this. The next one you have is the converse. The converse is where you exchange P and Q. So we're going to flip them from where they were up here, and now we have if Q, then P. The next one is the inverse. To write the inverse, we go back to the original statement, and it's the opposite of both of them, or it's the negation of both of them. So if not P, then not Q. Okay? And then the contrapositive is the opposite or the negation of the converse. So if you want to think of it, the converse and the contrapositive go together, okay, because they're opposites of each other. They're the flipped around ones, and then the conditionals of the conditional and the inverse are kind of basic. So it's the inverse is the negation of the conditional. Okay, so try to look through these. I might have made that a little confusing for you, so read through these so that you understand what each one would be. Now, one of the things they wanted to point out, and this is in the IM1 book, is just because a conditional statement and its contrapositive are both true does not mean that its converse and inverse are both false. The converse and inverse could also both be true. So you have to judge each statement on the basis of its validity, not just on whether other ones are true or false. Some people like to make generalities about that. Don't fall for it. Okay, a biconditional statement is when a conditional statement and its converse are both true. So if P then Q is true, and if Q then P is true, then you can write it like this and say it P if and only if Q. So here's how to write a biconditional statement. We've got the original, if two lines intersect to form a right angle, then they are perpendicular lines. But you can also say, if two lines are perpendicular lines, here's the converse, then they intersect to form a right angle. So we can see that both of these statements are true. We go back to the original conditional statement and say that one first, and then if and only if the second one. Okay, so if we had this one, we're going to rewrite this one. If an angle is a right angle, then its measure is 90 degrees. If an angle measure is 90 degrees, then it's a right angle. So this could be an if and only if statement. If an angle is a right angle, if and only if. Okay, this one, if Mary is in a theater class, then she'll be in the fall play. If Mary's in the fall play, then she must be taking theater classes. So they're saying that these are both true, so then we would make this statement. Now we're going to try to understand inductive reasoning. A conjecture is an unproven statement about a general mathematical concept that is based on observations. You use inductive reasoning when you find a pattern in specific cases and then write a conjecture for the general case. So here's writing a conjecture. So someone took the numbers 3, 4, and 5, which are consecutive integers, and they wanted to make and test a conjecture about what happens when you add the sum of any 3 consecutive integers. So they did that over and over again, and what they discovered was enough to make a conjecture. So they made a conjecture that the sum of any 3 consecutive integers is 3 times the second number. Then to test their conjecture, they used some big numbers, and it worked, and they used a mix of positive and negative, and it worked. So that way they felt that using this pattern, we developed a pattern that showed it was true, and therefore we know that that conjecture is true. Now, when you make a conjecture, you have to remember that if anybody can come up with one counterexample, one case where it's not true, then the whole thing is false. For example, when we're all in class and I say, everyone in this class is under 16, you might look around the room and say, yeah, everybody's under 16. But I am also in the classroom, so I am the counterexample for that case. Okay, so here's an example of a mathematical conjecture. The sum of 2 numbers is always more than the greater number. So you might go 3 plus 5 equals 8. Hey, that works. But then someone comes along and makes up this example. Negative 2 plus negative 3 equals negative 5. Negative 2 is the greater number, but negative 5 is not bigger than that. So because a counterexample exists, that conjecture is false. Deductive reasoning is not done by a pattern. They use facts, rules, definitions to form the logical argument. This is very different from inductive reasoning, which uses examples and patterns. So how do you compare them? So first we're going to decide which of these is which, if any of these, are inductive or deductive, and we're going to explain why. So each time Monica kicks a ball up in the air, it returns to the ground. So the next time Monica kicks a ball up in the air, it will return to ground. This is the conjecture. And we watched Monica kick that ball up in the air over and over again. So this established a pattern. So this would be inductive reasoning. Okay? All reptiles are cold-blooded. This is a fact. Parrots are not cold-blooded. This is a fact. So I made a conjecture that Sue's pet parrot is not a reptile. Therefore, I used deductive reasoning because facts about animals and the laws of logic are used to reach the conclusion. So, tonight's homework is not this worksheet 6A. It is a worksheet about algebraic proofs, and you're going to use the properties that you learned in 6th and 7th grade about commutative property, associative property, distributive property to give the reasons to support each statement of these algebraic proofs.